Okay, all the team participants, team members, uh, I would like to request you all to put your team name in brackets. यूसुफ पंखा चालू कर देना. Lokesh,
Yeah,
just pin the participants, no?
yeah.
Guys, sorry for the delay. We'll be starting the event in 5 more minutes. Okay.
Yes.
Lokesh, are you done with pinning the participants?
16 people can't be pinned. I'll like uh pin 2, 3 people from each college.
Yeah. Okay. So from ISC, just pin their front cams, and from other teams, pin 2 or 3 people. I assume Jazer is. Uh,
I would like to request all participants to switch on their cameras.
uh, Lokesh, just give Jazer the co-host permission.
Yeah. Only Arvind can do that. He's the host. I can't make people go.
Arvind.
Yes, yes, will be done.
Yeah. Yeah, I'm making you the co-host, so you will be able to manage the tiles better. Uh, Whenever you say we can start, we'll start. You can still pin them. Just check if you can pin them. Add pin, and then in the view section, you can shuffle them. It's fine, right? Okay, good. We'll start Devin. Krish, over to you.
Okay, we finally begin. Good afternoon and welcome to day 2 of ICER Pune and Praj presents Mimamsa Mains 2021. This is the rapid fire, the last quizzing event of Mimamsa Mains 2021 and probably the most thrilling, as some might argue. Jokes apart, I hope that you've had a filling lunch and have braced yourself because the rapid fire is going to take active participation from all of you, finalists and audience included. Here are some general instructions for the rapid fire. The rapid fire consists of 4 rounds and each round will have 4 direct questions. Teams get to choose the subject they want the direct question from, but one team can choose one subject only once in the entire rapid fire. Correct answer to a direct question will give you 1 point, and partial points may be awarded as per the QMC's discretion. In case the team answers incorrectly or partially, the question gets passed on to the remaining teams before the QMC reveals the answer. A correct answer to a passed on question will give you 0.5 points.
Manish, I'm sorry for the interruption, but one of the IITM members is not able to hear you. Could you wait 30 seconds? I'll try to figure it out.
All right. All the instructions that I'm speaking are already written in the slide, so even if they can't hear me, as long as they can see the slides and read, that'll be all right.
Okay, I'll just convey it to him. Sorry for the disturbance.
It's fine. Each team will get a thinking time of 60 seconds in which you cannot answer. You can discuss amongst yourself, but you cannot give your answer. You'll get an answering time of 15 to 20 seconds after the thinking time gets over. For passed on questions, there'll be no thinking time provided. The thinking time is common for all the teams, and all the teams should be ready for their answer with their answers. If the team to which the question is directed is unable to give the correct answer, you will be asked to give the answer immediately, without any lag. After each round, there will be an audience question, so the audience is suggested to stay vigilant. After the 4 rounds are over, there's also a trivia round for the participants. Points will not be awarded for the trivia round. Please note that cross-questioning the answers provided by the QMCs is not allowed. All queries will be duly addressed after the rapid fire wraps up. I ask anyone who has a doubt regarding the instructions to unmute and ask, because then we'll begin with the rapid fire. If there's any point that's unclear or you have any, and you think there's any discrepancy. I'll take that as a no. Okay, so we finally move on and begin the first round of rapid fire. The order that we have selected for the teams in all the 4 rounds is randomized. The first question of the first round goes to IIT Delhi. Which subject would you want your first question from? IIT Delhi.
Yeah, we'll take physics.
Physics. Question 1 of physics. How would you demonstrate to your friends that the Earth is a sphere without leaving the surface or circumnavigating around the planet? Your time starts now.
Hey Aditi, did you know? Although in the ancient past, people did think of Earth as a flat, people have argued since long against that view. Eratosthenes, a Greek philosopher living in the 3rd century BC, was one of the first to argue that the Earth was round. He even made an attempt to calculate its circumference. He knew that on the summer solstice, the sun was directly overhead at the noon in the city of Sin, and there were no shadows. In Alexandria, he measured the angle of the shadow cast by a long stick at noon on the summer solstice and found it to be 7.2 degrees. He hired binomists, professional surveyors trained to walk with equal length steps to calculate distance between Sin and Alexandria, which turned out to be 5,000 stadia.
The time is up. IIT Delhi, present your answers.
Right. So the thing is that am I audible?
Yeah, you are.
Right. So whenever we see the shadow of the Earth falling on the moon, regardless of the angle of the sun, the that shadow is always a circle, and that can only be possible if the Earth is a proper sphere. It cannot be possible if the Earth is a flat disk or any other shape.
Give me a second. Yeah, I think that's correct. Yeah, it's correct.
We move on to the answer slide, Amol.
Yeah. So the answer is correct, but we had there are multiple ways to answer this, and the answers that we had was that one is if you have a ship leaving a port, as it moves away, it would appear to sink, right, as it goes down. Second is you can use astronomical parallax, observe the same object in different locations across the Earth. The angle that it subtends should be different. And third is you just draw a large triangle and measure the angles, interior angle. The sum of the interior angles would add up to be greater than 180 degrees. So that's the three answers we have, but the answer that IIT Delhi provided is also correct.
We have a clarification.
Yeah.
The methods highlighted here, none of them prove it's a sphere. I mean, the ship moving away can also be true for an ellipse.
I'm sorry, Anirudh, but the clarification and
I mean,
cross
we can
questions
sure.
are to
No
be done
worries.
Yeah,
no
yeah,
worries.
after the rapid fire. Thank you. Well done, IIT Delhi. Now we move on to IIT Madras. Which subject do you want your first question to be from?
Physics.
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 Second question of round 2 from physics for IIT Madras. Consider a drop of liquid in free fall. If the mass of Earth were to increase, how would the shape of this drop change? Like any sane physics student, ignore air resistance. And your time starts now.
So here's a fun fact. The tides are also caused by a similar phenomenon. The moon's gravitational pull generates something called the tidal force. The tidal force causes Earth and its water to bulge out onto the side closest to the moon and the side farthest from the moon. So these bulges of water are the high tides. And as the Earth rotates, your region of Earth passes through both of these bulges each day. So when you're in one of the bulges, you experience a high tide. And when you're not in one of the bulges, you experience a low tide. So this entire cycle of 2 high tides and 2 low tides occurs most days on most of the coastlines of the world. So that certainly is something which will blow our minds away. Don't you think, Kasmi?
Yes, Aditi.
Your time's up, IIT Madras. Present your answers.
Yeah, so the volume of the droplet is going to decrease and it's going to become a bit more elongated.
Wait, will the volume decrease?
The volume of each drop will decrease because when the droplet's falling, it will split into more droplets because of the gravitation.
Oh, that's what you mean. Okay, and why does it get elongated?
In the end, I mean, because of the gravitational difference, like even the smaller drops will themselves get elongated. Like big drops will break into even more smaller drops.
Yeah, but why the elongation is happening, or why is it?
Yeah, like
down?
there'll be tidal forces, right? Like the tidal forces on the drop will be great.
Cool. That's correct. You can go to the answer slide. So basically, the different parts of the drop will experience different gravitational forces, and this depends on the gradient of the gravitational force, which is proportional to the mass of the Earth. So if the mass of the Earth increases, then the gradient increases, and this will happen.
Well done, IIT Madras. The next question, third question, goes to IISc Bangalore. Which subject do you want your first question from?
Yeah, we'll go with physics.
Physics. The third question of round 1 from physics itself is: suppose we model a solid as a cubic lattice of masses connected to each other via massless strings. This means that if a mass is displaced from its equilibrium position by x, it experiences a potential V of x is proportional to x squared. Will the solid expand on heating? Note that the strings are not real and just represent the interaction, and your time starts now.
Here's a cool fact. One of the tricks physicists use when trying to understand how a particle behaves near equilibrium is to approximate the potential near the equilibrium point as a harmonic potential. They do this by considering the Taylor expansion of the potential near the equilibrium position. However, this cannot be the accurate picture for arbitrary separation because we know that after a certain distance has reached, the atoms have to separate. Regardless, the harmonic approximation is very useful and can be used to calculate the specific heats of solids, coefficients of conductivity, etc., amongst other things. However, the thermal expansion is intrinsically linked to the non-linearity of the potential and hence cannot be captured by this approximation and requires symmetry. Nice fact, Aditi, right?
Yep, one gets to learn new things.
Your time's up, IISc. What's your answer?
Yeah, so our answer is that this solid will not expand on heating. The reason being is that the potential, the overall potential for the lattice, is symmetric with respect to expansion and contraction. From thermodynamics and statistical mechanics, we know that due to thermal fluctuations, the probability of a system being in a state with more energy than the ground state is e to the minus e by kBt. It's only a function of the energy. Since it's symmetric about this ground state due to the x square potential, we say that it's equally likely to expand and contract, and it will not do either. So
I'm sorry, could you explain what you said about thermodynamics?
So we said that from statistical mechanics, we know that due to thermal fluctuations, the probability of the system to be in a state with energy E is proportional to e to the minus, Euler's e to the minus e by kBt. We know that. And since both expansion and contraction have the same probability factor, neither of them will be particularly favored, and there will be no expansion or contraction.
Sure, I'll take that. Yeah, it's fine. Cool. So I will just add one thing that another mechanistical way to say this is that it will move back and forth, and since it is symmetric, the time averaged position of the particle is at the equilibrium position. So what you're measuring is the time average position of the particle. So again, it's the same.
Good job, IISc. We move on to IIT Bombay. Which subject do you want the question to be from?
We'll take chemistry.
IIT Bombay going on a different way. Chemistry. The first question of chemistry of round 1 is: in the image given below, the rotation activation energy of oxymethyl groups are given. Explain the trend, and your timer starts now.
Variety of techniques. And these methods are used for a variety of applications like X-ray, crystallography to determine the structure of the crystals. And X-rays have a wide range of uses in the medical field. Neutron scattering is used to study the structure of molecules as well as their vibrations. So for motions on intermediate scales, nuclear, magnetic resonance, NMR, it is a very widely used technique. And NMR has a lot of applications as well. The main one being in MRI machines for scans, and they can be used to determine structure of compounds and their purity as well, among many other things. So that is something to ponder upon for sure.
Yeah, so our answer is that the bond rotation barrier depends on the double bond character between the oxygen and phenyl ring bond. And in the third one, the double bond character is very high because the positive charge attracts the lone pair of oxygen. While in the second one, the double bond character is minimum because the benzene ring is already activated by the oxygen which is present on para position. So the resonance is very less. Where in the first one there is some resonance, but it is not as much as the last one because there is just normal resonance between oxygen and phenyl ring. Whereas in the third one, the resonance is greatly increased because the positive charge is stabilized by resonance due to oxygen.
Yes, your answer is correct. So the explanation given was correct. There exists resonance between the lone pairs and the pi system of the benzene ring. In the third one, because of the positive charge, there was more extended resonance. And in the second one, it was slightly lesser because there was no positive charge on the para position. In the first one, there is cross conjugation between the two para oxygens, which decreases resonance and hence decreases the double bond character.
Good work, IIT Bombay. And with that, the first round has come to an end. With all the 4 questions being done, we now move on to the first audience question. The first audience question is: it is a common observation that if you release the bob of a simple pendulum from a height, it will eventually come to rest. Assuming that there is no friction at the pivot and that the air in the room is an ideal gas, that is, small hard spheres which interact via elastic collisions, explain why the pendulum comes to rest. Audience, you can start. You can raise your hands and the QMCs will ask you to answer whenever you are ready.
Wait, I can't see the audience. So if someone raises hand.
I don't think we have any raised hands as of now. Any member from the audience? You can at least try to give the answer, even if it's wrong. Any takers? I think Sayan has raised his hand. Yes, Sayan.
So I think that since the pendulum is hanging from some support, right? So while it oscillates, it dissipates some amount of energy to that support, maybe?
That couldn't possibly.
All right, okay. So even if there is no friction, like there is this experiment, now if you have 2 pendulums which are hanging from the same support, after some time they
Assume that the coupling doesn't happen.
Oh, okay.
That's
Right,
not.
okay.
Yeah, that's not.
There's a chat from Mithil Kota to direct. The bob transfers momentum to air molecules via elastic collisions.
This was in the YouTube. Arvind?
Said by Mithil.
So the one question about that is, so the bob is transferring momentum to the molecules of gas. Why can't the gas molecules also transfer momentum to the bob? Both are equally likely.
One gas molecules is hit from both sides.
Sure, but I mean, it depends on whether it will transfer momentum to the bob or not. Depends on the phase at which it hits. It doesn't depend on which direction it hits.
Correct, but I'm saying it'll hit equally on all faces because air. Okay, I have no idea.
I think we can proceed with the QMCs revealing the answer.
So the answer is that almost so. If you consider this as a place, so one easy answer is to say that if you consider the scenario where the pendulum is stationary and the gas are moving faster, that has more entropy. So from the second law of thermodynamics, we say that is what will happen. But a more mechanistic explanation is that it is more probable that the energy from the pendulum goes to the gas molecules rather than that the gas molecules are transferring energy to the pendulum bob, because pendulum is one particle. There are many gas particles, and that the mass of the pendulum bob is a lot more than the mass of the gas particle. So yeah, essentially, it comes from Shatman, the Boltzmann distribution, which the IIC team talked about.
With that, the first round is finally concluded along with the audience question. Thank you, Sayan and Nitin, for participating. Now we move on to round 2. IIT Madras, it's your turn now to begin. Which subject do you want the question from? You can't choose a subject that you've already chosen.
Biology.
Biology. The first question of round 2 from biology to IIT Madras is: if a cell with an unpolarized membrane is placed in a concentrated solution of solute A, it does not swell or shrink. If a similar cell is placed in a concentrated solution of solute B, water moves out of the cell, and the solute B moves into the cell until the solution concentration on both sides of the membrane is equal. Why can't solute A equilibrate across the cell while B can? And your time starts now.
Through this question, we are trying to highlight the degree of selectivity that the cell exercises concerning substances entering and exiting it. Hiroshi Nikado, a Japanese microbiologist, is popularly known as the porenologist, as he single-handedly worked on the bacterial envelope at the University of Berkeley and is responsible for the discovery of porins. In 1969, he received the Paul Ehrlich and Ludwig Darmstädter Prize, and in 1984, the Hochst-Russell Prize. Both these prizes are well recognized in the field. Even at the age of 89, he continues to work at UC Berkeley.
IIT Madras, your time is up. What's your answer?
I think. Hello.
Yeah.
I think in the solution of solute A, the concentration of solute A is equivalent to that in the cell. Therefore, the osmotic pressure inside the cell matches with that of the A. Therefore, there is no inward or outer flow of the water, so it does not swell or shrink. But in case of solution of solute B, it has higher concentration than that inside the cell. Therefore, the water moves out of the cell due to the osmotic pressure difference. Therefore, the cell gets shrinked.
Okay, so actually here when we said in the first statement a concentrated solution of solute A, it implies that the concentration of the solute A is more outside than the cell's in initial concentration of solute A.
Okay, so it may be selectively permeable too, right?
Okay, wait, who's saying this? Can you elaborate a little?
Yeah, so like the membrane may contain proteins which only allows particular molecules to go inside and not the others. Like they bind with those molecules and let them in.
Okay, yeah, that's the answer. So can we move to the answer slide? So essentially the answer is correct. So we have membrane transport channels for solute B present on the cell membrane, but membrane transport channels for solute A are absent.
Well done, IIT Madras. Before moving on to the next question, I'll share with you the scoreboard of the previous round. Just a second. Yes, I'll represent it with the updated information. After round 1 and one question of round 2, the scores are as follows. Each team answered correctly in round 1 and IIT Madras gave a correct answer in round 2 as well. For the second question of round 2, I asked IIC Bangalore to choose a subject.
We'll go with chemistry.
Chemistry. Your question is, consider the two systems. System A, box full of nitrogen gas molecules on a spaceship moving at constant velocity. System B, box full of N gas molecules on an accelerating spaceship. I think I made a mistake. It's N gas molecules, not nitrogen. Which system has greater entropy and why? Explain in detail, and your time starts now.
So here's another fun fact to interest you, our audience. This question attempts to capture the essence of what entropy actually means. Entropy is a scientific concept as well as a measurable physical property that is most commonly associated with a state of disorder. Mathematically, a rigorous proof of the answer for this question can be obtained by finding something called the partition function, which is central to statistical mechanics and the link between the single molecule level and the macroscopic level. It has found far-ranging applications in chemistry and physics, in biological systems, and the relation to life in cosmology, economics, sociology, weather sciences, climate change, and information sciences. Well, I can go on and on.
Your time's up. What's your answer?
Yeah, so the system A will have greater entropy because system A is like it's like it's just the same like a box that's at rest. But in system B, there will be a pressure gradient due to the acceleration, which will kind of segregate the molecules. So the volume will be lesser, and system A will be more homogeneous, and hence we can say that A will have more entropy.
An additional argument would be that the moment we stop the acceleration, the box will spontaneously go into the same state as the velocity one, as the constant velocity. Other process. So it has to have greater entropy.
Right.
So it has to have less entropy.
So yes, your answer is correct. So yes, entropy of box 1 is more. This is because all spatial dimensions are degenerate in the box 1. Whereas in box 2, the acceleration adds additional force ma on the particle, which changes the potential energy along the accelerating dimension, thus removing the degeneracy.
Good work, IIC Bangalore. We now go to IIT Bombay for the next question. Which subject do you want?
Biology.
Biology.
Biology. The question is, as seen on the left, most drugs have a treatment profile where their effects directly correlate with their blood plasma concentration. Give an example of medication or treatment that has the treatment profile on the right. And your time starts now.
The underlying concept of this question is a pioneer in its field, and it revolutionized the manner in which we thought of therapeutics. The Nobel Prize of Physiology and Medicine in 1908 was awarded to this distinguished gentleman who played a major part in developing this process. He is also responsible for theorizing the magic bullet. In World War II, it was discovered that mustard gas, which was primarily a weapon, could drastically reduce the white blood cell count in the people that it was used on. This observation wasn't very unique. in the context of the war, as there were many more adverse effects that it caused, but it eventually also paved the way for this new technique. Isn't this interesting?
What's your answer, IIT Bombay?
So, as looking at the second graph, one example which we got up to could be as the drugs which are given in cancerous patient, like during chemotherapies or something, like which given in certain level of concentration are initially toxic, but we give counter medication or drugs in order to curb down their toxic effects so that they could be given in a higher concentration for them to be therapeutic. Maybe I don't know the name, Taxol or something.
Sure. Yeah. So the answer is correct. So chemotherapy was the answer we were looking for.
Yeah.
Can we just move to the answer slide? Yeah. So essentially, these chemotherapeutic drugs are used in such a toxic dose because you essentially want to kill off the cells. And that's why you see these kind of graphic profiles for anti-cancer drugs. And yeah, that's the answer. So you were right.
Good job, IIT Bombay. For the last question of round 2, we go to IIT Delhi. Which subject do you want your question to be from?
We'll take mathematics.
Mathematics. The first question from mathematics in the rapid fire game is: show that you can color the vertices of a 4-dimensional cube with 2 colors such that every edge has endpoints of different colors. Your time starts now.
So here's an interesting thing that I came across the other day. This result actually turns out to be true in general for the n-dimensional hypercube. This is called a Hamming cube. These are of extreme relevance in the subjects of information theory and coding theory. The question they try to answer is, how can we achieve perfect communication over an imperfect, noisy communication channel? Coding theory, in particular, deals with the study of error-correcting codes. These are algorithms which can detect and correct errors in a string of bits that emerge when the string is passed through a noisy channel. Well, noise pollution doesn't seem like much of a problem now, doesn't it, Asmi?
Yeah, yes, Aditi.
Your time's up, IIT Delhi. What's your answer?
Yeah, so note that in a cube, like the adjacent vertices, if you take the sum of the coordinates, they will have different parity because like they will have Hamming distance of 1. So one coordinate will change from 0 to 1 or vice versa. So we can just color all the vertices with odd sum of coordinates with one color and even sum of coordinates vertices with other color.
Yeah, that's absolutely correct. So you can go to the answers page. So yeah, so we've given essentially the same argument that you can identify the vertices with the elements of the set 0 and 4, and yeah, as Saumil said, 2 vertices are endpoints of an edge if and only if they differ in exactly 1 bit position. And so the endpoints of an edge will have different parities of the number of ones in the coordinate. And now we can just create 2 sets, one with vertices that have an even number of ones, one with vertices that have an odd number of ones, and then color them different colors, and that will ensure that every edge has endpoints of different colors. Yeah.
Nice work, IIT Delhi. With that, we conclude round 2 as well. We move on to the audience question for round 2. The audience question from chemistry is that a company wants a high yield of silicon and purifies it via zone refining. They take 2 different setups. Setup 1, silicon in the zone refining instrument as it is. Setup 2, silicon in the instrument along with a crystal seal of silicon placed at the base. Which setup gives a higher yield of silicon crystals in just a single cycle, and why? I'll read the question again. A company wants a high yield of silicon and purifies it via zone refining. They take two different setups. Setup 1, silicon in the zone refining instrument as it is. Setup 2, silicon in the instrument along with a crystal seed of silicon placed at the base. Which setup gives a higher yield of silicon crystals in just a single cycle and why? Participants, please raise your hand. Audience members, please raise your hands if you want to answer the question. We'll wait for a few moments until more people get the time to read the question and understand and come up with an answer. QMCs, can you see the people with the raised hands?
I see none.
Okay, so
I see Manas Raikar. Yes.
Yeah.
Yeah. So the principle of zone refining is basically differential solubilities of the impurities and like pure metal from in the like liquid. So when like it's so when the silicon starts recrystallizing after after it is like after it is melted and then it starts recrystallizing. So having a crystal at the bottom will help it to like recrystallize better, and that is why setup 2 will give it a give a higher yield of silicon in a single cycle.
Yes, so that is correct. Could we have the answer on screen?
There are no answer slides. I think you'll have to give the answer.
Okay, so yes, whatever explanation that Manas gave is correct. In the setup 2, the crystal seed of silicon accelerates the process of crystallization because it is a nucleation point. So that explains it.
Yeah, excuse me, Team IC here. Our main laptop just. Yeah, okay, the network is back on. Yeah, sorry.
Okay. With that, round 2 is completed as well. We'll go to the scoreboard and see the updated scores. I'll just refresh. Yep. Even after round 2, all teams are neck to neck. All the teams gave the right answers and they're all at 2 points. We now go to the next question, which is the first question of round 3. First question of round 3 is directed towards IISc Bangalore. What subject do you want?
We choose mathematics.
Mathematics. Question from mathematics for IISc Bangalore is: find a closed form expression for the expression GCD a raised to the power m minus 1, comma a raised to the power n minus 1, where a, m, n belongs to n in terms of the given constants and functions. Your time starts now.
The greatest common divisor, or GCD, of two numbers is commonly calculated using an algorithm attributed to Euclid of Alexandria, who described it in his book Elements. The Euclidean algorithm has many theoretical and practical applications. It is useful in a variety of cryptographic protocols and in methods to break certain cryptosystems by factoring large composite numbers. On the other hand, the Euclidean algorithm shows up in number theory and in particular helps to prove the uniqueness of prime factorizations. The original algorithm was described only for natural numbers, but the algorithm was generalized in 19th century to other types of numbers such as Gaussian integers and polynomials of one variable.
Your time's up, ISC. What's your answer?
Yeah, so the answer we go with is a to the power of GCD of m and n minus 1, like outside the exponent. And to prove this, we can use Euclid's division lemma, which we use to compute the GCD. And so one step in the expansion, one step in this process I can give, that will be a to the m minus 1 minus a to the m minus n times the second term, a to the n minus 1. Here, without loss of generality, I'm assuming m is greater than n. So we'll see that doing this step is the same as doing one step in the calculation of GCD of the exponents. Yeah.
Yeah, that's absolutely correct as well. You can go to the answer. Yeah, it's essentially that. So use Euclid's algorithm to show that you reduce and you show, and you can see that in the end it will simplify to a to the GCD of m and n minus 1, which is what Mimamsa said to.
I'll stay on this slide for 5 seconds for people who want to look at the answer. Good job, IISc. Alright. We now move on to IIT Bombay. Which subject do you want your question to be from?
Physics.
We'll take physics.
Physics. Yes. The question from physics for IIT Bombay is: a coffee cup is shown in the figure. An odd design is seen on the surface of the coffee cup due to some optical phenomenon. Provide an explanation for it. This, yeah. Timer start. Okay.
So, although we are taught about spherical, circular mirrors since school times, the actual mirrors used in receivers, telescopes, are parabolic in nature. Now, why would that be so? This has to do with something known as spherical aberration. It is a fact of Euclidean geometry that if you have parallel rays incident on a spherical surface, concave of course, the rays don't intersect at a point, but different rays intersect at different points. And the envelope of these intersections is what is actually seen in the image. Now, this is known as the caustic. This can be easily seen using ray tracing. When we derive the mirror formula in school, we often ignore the edges of the mirror. This is why it seems that most of the ray is focused at the focus itself.
Your time's up. What's the answer?
So actually, when light comes at an angle, not from the top of the cup, the opening of the cup appears like an ellipse when you look from the direction of the light. And in ellipse, whenever we get light which is coming from a distant source, parallel rays, two cusps are formed from the two due to reflection from the edges of the ellipse. Two cusps are formed from the which are centered around the foci of the ellipse. And when these two cups meet, we get the shape, heart-like shape, which is formed at which we can see from the top of the cup.
One small clarification. So suppose instead of this, I had a circular mirror, spherical mirror, and I put a parallel rays at it, parallel to the optical axis. Will you still see this? Like if I, of course, if I keep some surface, and I see what the pattern is forming, will you still see this, or a spherical mirror?
Are you talking about like you have a spherical mirror and directly rays are coming parallel to that?
Yeah.
No. In that case, the rays will just be focused at the
then I think
focus of spherical mirror. This is only for
we'll have to pass. I think.
Okay, the question is being passed on to IIT Delhi. What's your answer?
I mean, this is when light rays come from a source, then the reflected and the refracted light rays, the figure we see is the envelope of all of the rays converging at a point.
So you mean envelope of what?
envelope of all the figure which is shown in the question. At any point we take a light ray, that will form a tangent to the figure. The light ray will be a reflected,
that's absolutely correct.
Reflected or refracted ray anyway.
Yeah, that's correct.
You go on to the answer slide?
Yeah. So basically, this happens because of spherical aberration. A spherical mirror doesn't actually focus light to a focus point. For that, you would need a parabolic mirror, because the edges, they don't reflect light to the focus. They will reflect to some point below the focus. So if you draw the curve, you will get something called this. This is called a nephroid curve. So could you go to the next slide, please? There is the image for that. If you do the ray tracing, you will see this curve being formed. And this is basically the projection of that curve onto the coffee surface. So yeah.
Good job, IIT Delhi. We move on to the next question, which is directed to IIT Delhi. This is the directed question, not a passed on question. Which subject do you want your question to be from?
We'll take chemistry.
Chemistry. Question for IIT Delhi from chemistry is, explain the reason for the below reactions giving different major products. Your time starts now.
We know that selectivity in rearrangements is majorly affected by the electronic nature of both the migrating group and the group that is left behind. But there is more to it. Stereochemistry matters too. As another example, if we had the NH2 group in the equatorial position, irrespective of the position of the OH group, the product would be 3-tert-butyl cyclopentane 1-carbaldehyde. Such kind of rearrangements can be explained by the orbital overlaps of the rearranging groups, because only effective orbital overlaps give the correct rearrangement products, and these orbital overlaps are governed by the stereochemistry of the initial reactant. Isn't this interesting?
What's your answer?
All right, so the first reaction is an elimination reaction. The NH2 and the H on the oxygen leave, and you get a double bond. In the second reaction, you have neighboring group participation or ankymeric assistance. The lone pair on the oxygen attacks the leaving site of the NH2, and you get the compound that's there.
Could you elaborate on the first one?
The first one is so it's an elimination reaction. You go. Okay, wait. Aval has a go ahead. Aval.
Aval is muted.
You need to be more prompt, IIT Delhi, or we pass on the question.
Right. So what I think will happen in the first cases, the NH2 will be converted to a diazo compound, and then after that, what will happen is due to the HCl.
Yeah. So one thing that I'd like to mention is that first an enol might be formed, and then that enol might rearrange to this ketone.
I'm sorry, I'm gonna have to pass the question.
The question is getting passed to IIT Madras. What's your answer?
Yeah, in the first thing, the NH2 will get converted to N2 plus Cl minus, and in the adjacent side, the carbon to which the OH is attached, there is another hydrogen which is attached and which is like in the antiposition to NH2. So the Cl minus will attack that H plus, and there will be a minus charge formed. That minus charge will like attack, and N2 will be like N2 will evolve, and we will get like an enol compound that will tautomerize to ketone. And the second thing, the OH is directly like directly opposite to NH2. In that case, the NH2 due to that reaction between NaO2 and H, that NH2 will get converted to N2 plus and N2 plus Cl minus. So OH, that lone pair OH will directly attack to to the carbon which is attached to NH2, and it will remove N2. Thus N2 will evolve, and that will form OH plus, and from that the Cl minus in the solution and the H plus will get removed from the O, and that will give us the O which is above the plane in the second product.
So this answer is correct. So the key point of this question was that the attack always happens from an anti position or a trans position. In the first one, the H is trans to the azide diazo group that is being formed, whereas in the second one, the OH group is. Why it needs to be trans? Because proper orbital overlaps only occur in this trans position.
Good job, IIT Madras. We now move on to the last question of round 3, which goes to IIT Madras. This will be the direct question, and the last one was the passed on question. Which subject do you want your question to be from, IIT Madras?
Chemistry.
Chemistry. Question from chemistry for IIT Madras is, why does the following complex form with germanium but does not form with tin? Time starts.
This germanium complex that is seen here is useful in organic synthesis. When a chelating nitrogen ligand is used, which has pyridines and imine groups, one can synthesize a piperazine product with two pyridine groups at beta and gamma positions. This synthesis involving a step is called reductive cyclization. This compound used to be considered hard to synthesize or extremely elusive. But this germanium complex was able to synthesize this with reasonable yields. Another thing to think about this question is that this germanium complex is a part of the first paper of an IISER Pune professor, and her name is Maumita Majumdar. She was also responsible for the synthesis of the elusive piperazine product mentioned earlier.
IIT Madras, what's your answer?
In the periodic table, tin is just below germanium. So, and as you go down the periodic table, the size increases, and moreover, the like the tendency to donate electron also decreases. So, it'll be relatively more difficult for the tin to donate electrons to silver as compared to germanium.
So, could you explain the why does tin reduce its ability to give electrons?
So there is like the rest of the electrons they sealed the nucleus in case of tin, and so the last two electrons in the tin they are not like in more attracted towards the nucleus. So in that case it can form, I mean it can easily get reduced, so it instead of coordination bond it will prefer to form ionic bond. And also in case of tin, since its size is larger than the germanium, so like coordination number 5 will be difficult.
Did you say they form ionic bonds? I couldn't hear that.
Yeah, because of that
so no,
inert pair effect.
Wait, could you repeat that?
Yeah, because of the inert pair effect, the last electron.
Yeah, okay. The answer is correct now. The whole point is the inert pair effect exists in tin and not in germanium. That's the answer, because the two s electrons don't get involved due to shielding in tin, whereas this does not happen in germanium.
Good job, IIT Madras. With that, we conclude round 3. We move on to the audience question for round 3. The audience question reads, Khanna stands at a point on the boundary of a hollow sphere and fires a bullet at an angle theta with respect to the tangent plane at that point, or equivalently pi by 2 minus theta from the radial axis. The bullet reflects ideally within the sphere. For what values of theta will the bullet eventually return to Khanna's position? The audience member are requested to raise their hands if they have the solutions ready. We'll wait for a few moments until everyone has the chance to properly read the question. I'll say it aloud once again. Khanna stands at a point on the boundary of a hollow sphere and fires a bullet at an angle theta with respect to the tangent plane at that point, or equivalently pi by 2 minus theta from the radial axis. The bullet reflects ideally within the sphere. For what values of theta will the bullet eventually return to Khanna's position? Shooting of bullets is not endorsed by Mimamsa, and this is just a fictional question. Just putting it out there. We have people with their hands raised. QMCs, can you see them?
There's also an answer.
We'll wait for a few more moments before
We'll wait for some more time. We also have answers from the text messages, so we'll also be reading them. So as and when in around some time, we'll start off with the person who will also send the answers via text. Thank you.
Yeah, okay. Shriyansh, you can maybe try answering the question.
Can you hear me?
Yes,
Hello?
we can hear you.
Yeah. So I guess for any angle, it should reflect back.
Why?
Because if he's shooting from at any angle, the bullet will reach the diametrically opposite angle. Wait. Can I give another answer?
Sure.
It will be either 0 degree, 90 degree, or 45 degree.
Those will work, but that's not an exhaustive.
Okay.
We'll pass this on to someone else. Maybe Jharnesh.
Yes. There's an answer from the text box from Mithil. He says it's pi by n, where n is a natural number. For these angles, regular polygons are formed in the circle, except n equal to 1.
Right. Again, that's for those it should work, but because you get a regular polygon, but that's again not an exhaustive list. There are more.
We'll move on to Jharnesh. You can unmute and try answering the question.
Yeah, am I audible?
Yeah, you are audible.
Yes, so the answer is 0 and 45. I think that's what Shriyansh answered to, and again, they will work, but there are more options that you have. Okay. Marvin, do you have any more answers? No, I don't. Okay. I guess you can move on to the answer stage.
Yes, there isn't an answer slide, so we'll have to get the answer.
There isn't. Okay. So we'll make a few simplifications. First is that we'll work with the angle from the radial axis, and it will be clear why that doesn't make a lot of difference. Secondly, we'll be working in a circle and not a sphere, because if you send off the bullet from a sphere, then its trajectory will lie in a circle. So what will happen is that once you fire the bullet at an angle theta from the radial axis, after a collision, an angle of 2 theta gets added to the angle. So what you want is that after a while, the bullet should come back. So what you want is that the angles that are being added, they sum to some multiple of 2 pi. They need not sum to exactly 2 pi. They can sum to some multiple of 2 pi. And if that happens, then eventually you will come back. And so what you have is that 2n theta, because after each collision, the angle goes up by 2 theta. So 2n theta equals 2m pi for some n and n, which are natural numbers. So that tells us that theta equals m by n pi. And those are all rational multiples of her. Yeah, so that's the answer. A fun fact would be that if you send it from an irrational multiple of pi, then it won't ever come back, but it will. So the points eventually they will form like a technically will form a dense subset of the circle. So you'll get arbitrarily close to any point on that circle eventually. But yeah, you won't come back exactly to the starting point.
I think the answer slides have been added. We'll try and see. Yes, mathematics audience question. This is the answer slide. If anyone wants to read it. All right, so now we move on to the scoreboard. Let's refresh the scoreboard. And yes, as you can see, after round 3, these are the scores. ISC Bangalore is at 3 points, IIT Bombay 2 points, IIT Delhi 2.5 points, and IIT Madras 3.5 points. We'll now move on to round 4. The first question of round 4 will go to IIT Bombay. Which subject do you want?
Mathematics.
The question for IIT Bombay from mathematics is: a partition is defined to be a finite list of natural numbers a1, a2 through ar in decreasing order. Show that the number of partitions with the first term equal to n is the same as the number of partitions of length n. And your time starts now.
So, it is a well-known fact that all integers can be expressed uniquely as a product of pairs of primes. This is called the fundamental theorem of arithmetic, and it determines the multiplicative structure of the integers. One can similarly investigate the additive structure of integers, wherein we try to express integers as a sum of elements in some subset of the integers. The study of partitions is an important question in additive number theory. Several important contributions to this subject came from mathematicians Hardy and Ramanujan in the early 20th century. They were interested in studying the partition function, which gives the number of partitions of a natural number n. When no closed form expression for the partition function is known, they derived certain asymptomatic expressions.
Your time ends, IIT Bombay. What's your answer? IIT Bombay. You're muted if you're trying to answer, and we can't wait so long before an answer is given. The thinking time is over.
Yeah,
I guess
the number of partitions which we can create with first term n, we can either include or not include each of the numbers from 1 to n minus 1. So the number of partitions would be 2 raised to n minus 1. And similarly, when we have the partitions of length n, the number of partitions will also be 2 raised to n minus 1, because we can start from 1, we can start from 1, 2, 3, and similarly we can take any n numbers and then take cases whether they are present or not present. So equivalently, we always get 2 raised to n minus 1 partitions.
Wait, can you repeat why the first number would be 2 to the n minus 1?
Because when the first number is n, for each of the numbers from 1 to n minus 1, we can either take 1 or not take 1. We can either take 2 or not take 2, and there is no arrangement in it. Like if we are choosing a particular set of the numbers, there will be a fixed arrangement in decreasing order. So the number of partitions in both cases is 2 raised to n minus 1.
Okay, so when you arrange them in decreasing order, that doesn't give you 2 to the n minus 1, right? It gives you n factorial.
But we need to choose from like suppose n is 6, then we need to choose whether each of the numbers from 1 to 5 are present. No, like
so the numbers need not be starting from 1 to n. They are arbitrary numbers.
Can I speak?
Sure.
Yeah, I think this is wrong, since the number of partitions which start with n will be finite, since it is obvious, since if the first term is n, then the next term will be less than n, and the next to next term will be less than so, and so on. So the number of partitions will be finite, since it will be less than n factorial basically. While for length n, we can arbitrarily choose any number m larger than n and define the partition as m comma m minus 1 comma m minus 2 up to m minus n plus 1. So the number of partitions of length n is infinite.
Okay, I see what's happened here. Yeah, so I'm sorry if it was not clear, but a partition is of a number, right? So this is a partition of a1 plus a2 plus a3 up until a, right?
Addition, where did the addition come from? Isn't it simply a finite sequence?
The question does not make it clear anywhere.
Yes. For example, say n is 2, then the only partitions are 2 or 2 comma 1.
No, I get what you were saying.
Starting with 2. While for length equal to 2, I can choose 100 comma 99, 99 comma 98, 98 comma 97, or 2021 comma 2020.
Yeah, I'm sorry if it was not clear, but that's what the intention was. Yeah, we maybe missed that. So do you want, can we
I feel we should get the point then.
You want to try to answer the actual question then? You can, I guess.
Can you clarify what is the actual question? Like,
okay, so the question is that okay, so you have a number which is a1 plus a2 plus a3 up until ar, right? That's the number, and you can have its partitions, right? Like you can partition it into numbers, a sum of numbers.
And those numbers need to be distinct, or
no, they need not be distinct.
Okay.
And so you can arrange them in a list now, the partition that you get. And
so basically the sum of numbers a1 to ar is constant. That is the parameter.
Yeah, I guess you
can mention it. And that length n thing, how do you define a partition of length n?
I'm sorry, the r here is the length of the partition.
Can you repeat?
Okay, so 5, you can partition it into 1 plus 1 plus 1 up until 5, right?
Yeah.
That length is, so the length of that partition is 5, but you can also partition it into 5 plus 0, or as in just 5. And the length of that partition is 1. You can partition it into 2 plus 3, and that the length
then of the partitions of length n can be infinite. I can choose any n natural number, then show them to be the partition of.
No, we are restricting ourselves to the partitions of a fixed natural number k. Yeah.
Yeah, but then the length n partitions would be 1.
Length n partitions of that.
Because that would only be 1 plus 1
it's
plus
not
only.
Okay. It's not. These are not the partitions of n. N is a number, and we are talking about partitions of a1 plus a2 up until a. That is fixed.
Sorry, can you repeat?
Okay, so a1 plus a2 up until ar. That's sum. That is
is
fixed.
Yeah.
That is n. No, that is not n.
Okay, that is.
N is a different number. Yeah.
Okay, what is that fixed is some
a1.
Number.
Yeah. Right. What is fixed is the sum of the elements in the list.
I still.
Okay. Yeah. I guess we are wasting our time here, so maybe we can award you points.
Question.
Do we go to the answer side or do we move on?
I'm sure. Yeah, we can go to the answer side.
Okay.
Yeah.
So will we get the point there?
Yeah, we'll award you points. I'm sorry for the inconvenience. So the intended solution is that, so we have this partition and we can represent it graphically as an array of points with a1 points in the first row, a2 in the second row, and so on. So the proof is a bijective proof. So we show that the we show that the set of partitions with largest term n is in bijection with the set of partitions with total number of terms n. And how we do that is we take this graphical representation and we take its transpose. I think we flip it along the diagonal. And so if the largest term is n, what will happen is that in the transpose, you get a partition which is a valid, so you get a diagram which is the diagram of a valid partition with total number of terms in. And we can show that these two sets are bijective under this correspondence, and thus they have the same number of elements.
When you say decreasing sequence, then 5, 3, 3 should not be allowed, no, because 3 and 3 are equal, 4 and 4 are equal. So
okay,
it's not clear whether it is decreasing or not.
Yeah, the question was pretty
I mean,
unclear for the most of the time, and neither did we get 1 minute for thinking for the original question, nor did we get the correct framing of the original question.
Yeah, we will
This is
still
a bit unfair.
we will still award points. We are scrapping the question.
Okay. We now move on to the second question of round 4. The second question goes to IIT Delhi. Which subject do you want the question to be from?
Yeah, only bio is left, so.
Biology. The question is, why should receptors with n binding sites for the same molecule exist if the strength of one such receptor is less than the collective strength of n receptors with one binding site each? The time begins now.
Then again, we've been learning from school that receptors are chemical structures composed of protein that receive and transduce signals that may be integrated into biological systems. These signals are typically chemical messengers which bind to a receptor and cause some form of cellular or tissue response. Receptor proteins can be classified by their location. Transmembrane receptors include ligand-gated ion channels, G-protein coupled receptors, and enzyme-linked hormone receptors. Intracellular receptors are those found inside the cell and include cytoplasmic receptors and nuclear receptors. Now, this question tries to draw the attention of the audience to an important concept of biochemistry, which is not really limited to biochemistry, but all others extends to all other subjects as well.
What's your answer, IIT Delhi?
So what we think is that maybe the reach will be if you have like n different receptors in they will be spread out. So it will be harder for the molecules that bind, which will be I think close together, to bind to the different receptors, and maybe it also takes more resources to make n receptors as compared to just one receptor.
Okay, this is a little unclear. You want to elaborate on that? So the energy point is an assumption which you are making. So maybe elaborate on the earlier part if you want to. Otherwise, we can pass the question.
So basically, if you have more, if you have n binding sites for the same molecule, it is more likely that the molecule gets captured by the receptor because you've got more binding sites. So it's more probable for the molecule to get for the receptor to receive the molecule.
But essentially won't having more number of receptors with a site help us, because you will have more receptors binding to more binding sites, and that's why you will have a similar response, because eventually we are keeping the number of binding sites same, right?
Again, that's the cost thing, because receptors are it's easier to have receptors on it's easier to have more binding sites on receptors than it is to have more receptors with one binding site.
Okay, I think, yeah, let's pass the question.
The question goes to IIT Madras. What's your answer?
Yeah, I think like suppose there is a molecule. If we bind with n receptors with single binding site each, then it won't make a stable binding because those binding those binding receptors are individual enough. If we make a single receptor with n binding sites, that will make a stable binding because individual those are not like the individual binding sites which are like independent of each other. So a molecule with n binding, a receptor with n binding sites will make a very stable binding with the molecule. So I think that's the answer.
Okay, so like your answer. Okay, yeah, go on. If you want to elaborate, you can.
Like I guess another way we can think is like
in like essentially like we need one output, right? If there are n different receptors, then we can get multiple outputs, which may not be proper. Like for example, if in the case of a single receptor, like even if many molecules come together at the same time, like only one single output will be produced. But if there are many, like there's a possibility that many molecules might go to each receptor and each will give its own output, so it might actually not be an effective way.
Okay, yeah, I guess we'll take this answer. Yeah. So can we go to the solution slide? Yeah. So essentially what Shrivas said right now was correct. So when you have a single receptor with n binding sites, you have a more thresholded and a sensitive response so that you can monitor reactions more accurately. Whereas in terms of multiple receptors having a single binding site, you will have a more binary response, which is not as accurate. So just to add on to this, so there's this concept called the Hill's reaction in enzymes and kinematics and stuff. And that's why this is Hill's reaction helps you prove this. So if you guys want to look it up for more clarifications, you can.
We now go to the third question of round 4. The third question is directed towards IIT Madras. The last question was a passed on question. IIT Madras, your question should be from which subject is left? Mathematics or biology? Mathematics. Consider a situation where a password, a real number in this case, needs to be shared between the manager of a bank and 2 members of a family who hold a common account in the bank. This needs to be done in such a way that the manager, together with one of the family members, family members, can deduce the password, but not otherwise. Devise such a procedure using the hint in the accompanying video. We'll play the video.
Yeah, you need to share computer audio. We can't hear anything.
Could you also show the text for, I mean, 1 more minute? Like, I didn't read the full thing.
I'll first share my audio. Yes. And I'll first play the video and then show the text. Okay.
Into maths, we now have a think, what mathematical situation or object has the properties that match what we're after? In this case, we want something where if you get one bit or another bit, it doesn't give you any indication as to what the whole thing is, but if you get both, it perfectly defines it. And that sounds to me like a straight line, because if you've got 1 point, that could be any line, but if you've got 2 points, that perfectly defines the linear equation of that line. So now I've just got to turn this into a linear equation. First of all, I randomly generated a number that was between 0 and 100 million, about the same scale as what I'm trying to hide here, and I got 41,366,362. Don't try and look for meaning in that. I've not hidden anything. Genuinely, I generated that at random. So that's going to be the gradient of my line. So now if I want to split this secret between 2 people, the first person's share is the coordinate 1 and then 60,577,000, so on, and the second person gets 2, 101,944,000, and so on. So if you just got one of those 2 points, the line could be absolutely anything, and if you get the other point, the line could be absolutely anything. Only if you have both the points and you work out the gradient of the line and you carry it down to the vertical axis, where it crosses is the point 19,211,319. I've encoded my secret as the vertical intercept of this line, or what you get if you put in a value of 0. So basically, it's a polynomial, and the secret information is the 0th coefficient.
So the question and your time starts now.
In this question, we look at a scheme of secret sharing. These are methods for distributing a secret among a group of participants, each of whom is allocated a share of the secret. The secret can be reconstructed only when a sufficient number of possibly different types of shares are combined. Individual shares are of no use on their own. One of the first such schemes is the SSS protocol we mentioned. This protocol of distributing a secret among many people in a secure way was first formulated by Adi Shamir in his paper How to Share a Secret and is based on polynomial interpolation. It is a remarkable algorithm with several practical consequences.
What's your answer, IIT Madras?
Okay, so what you can do is that the password can be represented on the y-axis just like in the video. So you can assign two coordinates which are parallel, like which lie on a line which is parallel to the y-axis to the two members of the family. And the third point for the manager will be such that, like when you draw the two lines, like joining the joining the two coordinates, it intersects on the required password. So if at all the two members they cannot reduce the password on their own because it will form a straight line parallel to the y-axis. But on the other hand, if they do it with the manager, it will intersect on the y-axis and that will give us the password.
So the line from the the manager's card. Okay, the information to the manager given is a point, right?
Yeah.
Yeah. So the line from the manager to the two people in the family, they need not have the same y-intercept, right? They will not have the same y-intercept unless and until the manager is himself on the y-axis.
Oh yes, that's right.
I think we'll have to pass this to the next.
You can try. Wait, yeah, we have one.
But I think you.
Yes, the question gets passed to IISc Bangalore. What's your answer?
Right. So when the brief sketch of the idea is this, we're going to define points in a 3D space like it was defined in the video. Consider such 3 points F1, F2, and M corresponding to the two family members and the manager respectively. And we define it as such that if you draw the line F1M, like connect those 2 points, and you intersect it with the XY plane, then the X coordinate is the password. Now, if you join F2 and M and you draw this line, and then you intersect it with the XY plane, the X coordinate is the password. Okay. And we can do this construction for, we can do the construction of the required M for arbitrary F1, F2s. So we're giving 1 degree of freedom, which is the y coordinate of the intercept on the plane, and the x coordinate will be fixed for both of the cases.
Yeah, I think that should work.
Yeah.
I think that should work. And do you have something to say?
Not really. Yeah, this seems like an acceptable answer.
Yeah. So our answer was on the 2D plane. So what you do is instead of a line, you use a circle. And so a circle is uniquely determined by its center and a point on it. So we need the center and the radius essentially. So giving a point determines the radius. So what we can do is we can give the two family members points on the circle. So by themselves, they can't really determine what the circle is by the. We can determine what the circle is by the using the 2 points. And so the manager will be given the center, and with that they can construct the circle, and the radius could be something that is the secret. That's the solution.
We move on to the last question of round 4 and the last question that will award you points in the entire rapid fire. This question is directed towards IISc Bangalore and is from biology, if I'm not wrong.
Yeah.
It's from biology. The question reads, the diffusion coefficient D characterizes the rate of movement of a molecule through various media. How would the value of D vary for a DNA and a protein molecule as the molecular weights increase from 1 kilodalton to 1000 kilodalton? And your time starts now.
It is interesting to note that the concept of diffusion coefficient was first introduced via Fick's law of diffusion. Apart from being a physician and a physiologist, he came up with mathematical representations of his laws. Interestingly, he was the first person to measure cardiac output. The method by which he measured the cardiac output is now known as the Fick's principle. Fick's work was inspired by the earlier experiments of Thomas Graham. Fick's law is actually analogous to the relationships discovered at the same epoch by other eminent scientists, say Darcy's law for hydraulic flow, Ohm's law for charge transport, and Fourier's law for heat transport. So that is certainly something intriguing and gives one food for thought.
What's your answer, ISC Bangalore?
So the difference that lies between DNA and protein is that DNA can supercoil at a certain length. So instead of it increasing continuously with increase in its molecular weight, at a certain point it will start supercoiling and basically coiling and supercoiling, and its diffusion coefficient won't increase naturally. So at very small lengths, actually the rigidity of the DNA will prevent supercoiling. So we'll actually see a small increase, then a sudden decrease because of the onset of supercoiling, and then finally a very slow increase as we get the more and more molecular weight. But proteins will show a more monotonous increase in diffusion coefficient as we go to higher molecular weights.
Okay, just to clarify, can you talk only in terms of diffusion coefficient for DNA ones?
Yes. So basically, the diffusion coefficient would be dependent on the effective cross-sectional area of the total molecule that we get. And so, since DNA at smaller lengths, at very small lengths, like oligonucleotide fragments would be partially rigid and won't take part in supercoiling. Hence, they will show a more or less linear relation in the first few things. But as the thing increases, we'll see more and more supercoiling, and hence its rate of increase, the diffusion coefficient might actually decrease at a certain point and then finally increase very slowly. Yeah.
Okay, I think we are going to pass this question.
What? That's the answer, right? Ulta kya?
The question is getting passed on to IIT Bombay. IIT Bombay, what's your answer?
According to Einstein's formula, the diffusion coefficient is given by kBt divided by 6 pi eta r. And since we are not given information about eta or r, which is the viscosity coefficient and radius, we will just assume that they are same for both. And we can see that this formula does not depend on the mass of the DNA and protein molecule. So in that case, diffusion coefficient will be same. But if we are assuming that the molecular weight of protein molecule is more, so the radius will be more. In that case, diffusion coefficient for protein will be lesser.
Okay, can you just tell us the plot in general? So what will it be for DNA and for protein, which will be higher, lower? That's all I want.
For DNA, it will be higher, and for protein, it will be lower.
Okay, and in general, what is the trend that you'll see?
So for DNA, the decrease in diffusion coefficient won't be as steep as in protein.
Okay, and no, we'd like to pass this.
The question gets passed on to IIT Delhi. What's your answer? We can't wait, IIT Delhi. Need to be more prompt.
We'll say that for DNA, it will decrease because of supercoiling, and for protein, it will increase.
That's your answer?
Yeah.
Okay, I guess we'd like to pass.
There's no more teams to pass the question to.
Yeah, I guess
the answer should be revealed by the QNCs. Yes.
Yeah, let's just go to the solution side.
So we have.
Yeah,
exactly.
We didn't go across.
Okay, and sorry, the question gets passed to IIT Madras.
Yes, I'll go to the.
Hey, we saw the answer. If we can see it, IIT Madras can also see it.
Yeah, I think we'll just
Okay.
tell you guys the answer. Yeah. So the supercoiling point which you made, that is so we had mentioned a range of molecular weights in the question. So supercoiling doesn't come into picture during the range of weights which you mentioned. And so essentially, as the molecular weight increases, proteins are expected to become globular because of the self interactions present between the constituent amino acids, which wasn't touched upon. And a DNA molecule doesn't have any such self coiling interactions. Usually you have mechanisms, etc. for that. And that's why as molecular weight increases, the D overall decreases, but the D of DNA is smaller than that of proteins. So DNA will be
Also,
lower. And
another point to add regarding supercoiling, it's not a thing that just spontaneously happens. Like supercoiling of DNA is a thing. Like you are correct in the sense that it becomes very compact, but it requires specialized enzymes. It's not just it does not spontaneously collapse into that sort of structure. Whereas protein folding is much more self-reliant.
Yeah. Okay, so I guess we are done. We can move to the audience question.
Yeah.
Sir, will IT Bombay get the point? Because I think our answer matched with that to a large extent.
I think that can be discussed after the rapid fire gets complete in the interaction hour. Yes, all the clarifications will happen then. With that, all 4 rounds of the rapid fire complete, we move on to the last audience question from biology. I think there's some issue. Let's just resolve it for a minute.
Okay, so I guess they are having some problem presenting the audience question. So I'll just read it out here. Yeah, I think it's a pretty simple question. So yeah, you guys can hear me, right?
Yes.
Okay. So yeah, there are 2 samples of DNA which are run on a gel electrophoresis and then later treated with ETBR. The first sample is of size 100 base pairs and the second one is of size 500 base pairs. Which band will have a greater intensity? And there are 2 parts to this. When 100 nanogram of each sample is loaded or 100 micromoles of each sample is loaded. So you need to compare the intensities between sample 1, which is 100 base pairs, and sample 2, which is 500 base pairs. When 100 nanogram of each sample is loaded and 100 micromoles of each sample is loaded. Audience. Yeah, I guess. Is there any way to, okay, can I share my screen if like these guys want to see the question? Or is this okay?
I think you can share your screen. Yes, that can work out. Do you have the permissions to do so? Like Zoom allowing you to?
No, I think you will have to stop sharing your screen.
All right.
No, I just gave you the permission to show.
Yeah, 1 minute. Let me try. Yeah, give me half a minute.
After the audience question, we'll move on to the trivia round, which has 4 questions. Any of the finalists can opt to answer that, but there are no points for that round. And after the trivia round, we'll show the final scoreboard. So as soon as we get done with this audience question, we'll go to the trivia round. Okay, I think the problem has been resolved.
Okay, can you?
Yes, I can share my screen and the question will be there. My screen is visible, I hope.
Yes.
Yes, now we'll go to the audience question for biology. Two samples are run on a DNA electrophoresis gel with ETBR, one with size 100 base pairs and one with size 500 base pairs. Which band will have a greater intensity when 100 nanograms of each sample is loaded, 100 micromoles of each sample is loaded? If there's anyone in the audience who's willing to answer, please raise your hands. And sorry for the inconvenience caused. We'll wait for a few moments before taking the answer.
Yeah. Arvind, anyone from YouTube chat? Okay, I guess. Yeah, I guess you can. Mithil, you can go ahead and try.
I have written this in the chat. So same number of moles means if you are using same number of moles, then longer DNA will be brighter because ETBR intercalates in between base pairs. So if you have more base pairs, then you have more ETBR and you will see a greater intensity. And if you have same mass, then you will see similar brightness. And same mass also means like total number of base pairs for both samples will be the same.
Yes, your answer is right. So I guess this is pretty self-explanatory. So essentially, more number of base pairs means more intensity.
Yes, and this is the answer slide. With that, the 4 rounds are finished along with the audience questions. We now go to the trivia round. The first question for trivia from physics is: X is a famous mathematical model from statistical mechanics. Although originally introduced to model ferromagnetism in solids, people have tried to use X to model all sorts of things, ranging from activity of neurons in the brain to the behavior of the economy. Identify X.
Can anyone answer, or is it?
Yes, you can raise your hands in the
Just
Q&C
raise your
well.
hands.
Yeah.
I think Team ISC has raised their hand.
Yeah, Team ISC, you can try.
This is the Ising model from statistical mechanics.
That's correct.
We go to the answer slide for a moment. Yes, it's the Ising model indeed. Now go to the second trivia question from chemistry. Which scientist introduced the idea of hybridization of orbitals to the whole world?
Yeah,
Aniruddha. Aniruddha?
Acha, you said, okay.
Yeah.
This is Linus Pauling.
Yes, it's correct.
I don't think we need to go to the answer slide for this. Or I think, okay, why not? Yes, the answer is there. The third trivia question from mathematics is: in mathematics, the theory of analytic continuation allows one to assign values to infinite sums that wouldn't otherwise exist. Using the analytic continuation of the Riemann zeta function, what seemingly paradoxical number does zeta minus 1 evaluate to? And why has this result become infamous on the internet in the last few years?
I would like to ask Team IITM the answer.
Okay. Team IITM?
Yeah, a minus 1 by 12. Right? Hello?
Yeah, that's the right answer. Why has this result become infamous on the internet in the last few years again?
It was in the paper of Ramanujam, right? When he showed it to Hardy, I guess. Is that in the movie?
It's there, okay.
Yeah.
Does anyone, I mean, that might be it. We have a different solution. So, does anyone else want to try?
I guess number file YouTube channel gave us wrong proof of this using summation of GP with constant term -1 or 1, something like that.
Yeah.
-1, I guess. Yeah.
Again, these are not counted towards the scores, so yeah, doesn't matter. Okay.
Go to the answers. Yes, it was popularized by the popular math YouTube channel Number 5, and the answer is -1 by 12. The last trivia question from biology is the issue comes up again.
Okay, should I present or are you fixing?
If you can present quickly, that'll be better.
Yeah, I think I can present pretty.
Okay.
Krish, if you press escape and present again, it will be fixed.
All right.
Sure,
Yes.
that works too.
The trivia question for biology reads: Sarah P. Weisskopf is a biologist associated with the U.S. Geological Survey. While in Bangladesh, she developed a new method for sampling the presence of mammal species in a specified area, often hard to detect through camera traps. This method involves the purification and amplification of blood samples found in the field, and such samples were found to contain a mixture of multiple species' blood: tiger, gaur, wildcat, etc. The separation using gel electrophoresis after PCR revealed up to 12 species in one single sample. The accessibility of samples is frequently affected by the presence of natural salts in the environment. Where did Weisskopf source these suspicious mixtures of mammal blood from?
Do any of the teams want to try answer?
Yeah.
Yeah,
I see. Go ahead.
Yeah, so we have a blind guess. So we're thinking of blind bats, and blind bats are mosquitoes, and they take the mammalian blood from the mosquitoes or the bats, and that's how they source their blood from the animals.
Okay, you are close, but that's not quite the answer.
Something that drinks blood. I don't know, vampires.
Surya, you can have a try.
Yeah, so I was thinking of mosquitoes, but now I think leeches.
Yes, that's the answer. Can we go to the solution
Yes.
slide? So I don't think the solution slide provides much information. So essentially the answer is leeches.
Okay.
Yeah, okay. Chris, carry on.
Yeah, with that we are done for the rapid fire, and yes, the final scores of the scoreboard are as follows. IISc Bangalore stands at 3.5 points, IIT Bombay with 3 points, IIT Delhi with 2.5 points, and IIT Madras with 4 points. It's clear that IIT Madras has won the rapid fire with 4 points, but it was a tight competition. As you can see, all the teams differ by only a 0.5 difference. With that, Mimamsa is drawing to an end. We are done with all the competitions in Mimamsa Mains 2021. The finalists have given their all to win the title of the winner of Mimamsa 2021. Stay tuned to find out who the winner is in the valediction ceremony, which will start at 5 p.m. Thank you, audience members, and see you soon at 5. A note for the finalists, if you have any questions, clarifications that you need to discuss, there's an interaction hour right after the rapid fire meet ends, and it will take place on the Discord server, the Mimamsa Discord server. So, yes, thank you for joining, everyone.
Yeah, see you guys and the interaction hour if you have any questions for the team. And we'll see you at the valediction ceremony at 5.